How's everyone doing? Welcome to the office hour number 12. So today's session, we're going to talk about, I would say, the biggest feature coming out with 1.4, which is the support of the tier storage. So with that feature, you will be able to using, like the standard S3 option in one folder and div archive in another folder in the same JuiceFS file system. So it's potentially could save a lot of money. I would say if you have a lot of code data and we are not to visit for rather expand of time, and then you want to keep it in the file system, so you don't have to just moving the data around. So this feature has been I would say it's been talking about by the community like since the 1.0, and finally we make it. So in 1.4 we support this so-called different storage class in the same file system, or tiered storage support. And I think there's also other new features coming out of 1.4. We probably need another office hour or so to talk about those. They're very helpful about the for instance the quota support and the performance improvement of metadata in operations. And also we got some improvement from the CSI driver. So today's session will host go through all these the exciting new feature by our developer Evelu Joey. And without further ado, let's welcome Joey to the stage. Joey, it's all yours.
Okay, so yeah, let's get started. Hi everyone, my name is Joe, and I'm the developer advocate at JuiceFS. And today I'm very excited to share with you this new feature, which is about the tiered storage that's released in the recent release, JuiceFS v1.4. And yeah, we call it how to code and back all in one command. So yeah, let's get started. All right, so for today, we're gonna cover a few topics. So we're gonna explain exactly what are those object storage classes, and then we're gonna see how JuiceFS is able to utilize them using the tiered storage feature. And we have some slightly advanced patterns for rewriting new objects or restoring from archives. And finally, we're going to share some best practices when you're using this feature as well. And lastly, as always, we take all the questions from the chat. If you're watching it live, yeah, it's a great chance to talk with us. If you have any questions, if you have any good comments or blockers when you're using JuiceFS, that would be great. Cool. So first off, the object storage classes. So what are these, right? So we all know that the data, they're gonna turn code eventually, right? So we have hot data, which is probably the most recent and also very business critical. That's the data we constantly query either by like a key or ID lookup, or by slightly more complex queries as well. And they need to be there, and they have like comprehensive indexes and everything, so that when we want to access this kind of data, it's always instant. Right? So it's very important for the business, for the product to run. Right? And then on the other end, we have this code data. It could be data that's been there for a long time. You can, yeah, I like to frame this as like in the timeline, because it's quite common, right? For example, when you look at your bank account, we tend to look at the most recent month. Sometimes we do need to go back to maybe 1-2 years ago, but most of the time we're doing, we're looking at the most recent data. It's very similar pattern for things like social media too, right? We tend to look at the hottest topic right now. Some news they don't like after a while they're not new anymore, so they turn old. Also for in the engineering world, right? Like when we use like a time series database or some sort of observability platforms, it's a very similar pattern again, where when we have something like maybe a P1 that or P0 that we need to solve in production, we look into the recent logs or events, not the old ones. But oftentimes we want the old ones or the code data to be there just in case. And in between, we also have this sort of so-called warm data where they're also available, but maybe slightly slower than hot data, kind of like a middle run for in between the two extremes. So that's hot versus cold data. And then let's take one of the best object storage service out there, S3, as an example. So S3 helps you to organize your hot, warm, and cold data using different storage classes. And S3 has a lot of them, right? So when the first time, so if you're using it like in general and you don't think about it, you're on the standard, right? So you're on a standard storage class, and once you discover this documentation page of S3, you realize that, oh, there are a lot of them, and it could be overwhelming. But if we categorize them, into different categories or patterns, it's not that hard to understand all of them, right? So first off, we have the active and frequently accessed tier, which is the S3 standard, is what we normally use every day. And we also have this S3 Express one zone. So compared with standard, so standard stores the data to at least 3 availability zones, right? So you need to reach consensus, no matter if it's like instant consensus or eventually it needs to be resilient. Whereas for one zone, S3 Express one zone, right, the data is stored only in one availability zone. So as a trade-off, it's less resilient, but it will give you like higher performance and lower latency. So yeah, S3 Express one zone is the most performant out of these tiers. But normally standard is also very good. It's the de facto choice. Then we have the infrequently accessed tier or storage class, right? So we have the standard IA or the one zone IA similar idea. But for these storage classes, they tend to have lower costs compared with the standard ones. But when we need to retrieve the data, we pay for a per gigabyte retrieval fee, right? So yeah, you start to see some of the trade-offs here, right? So the storage cost is lower, but we pay extra when we want to read. So, we probably don't want to access them that frequently. If that's not the case, it's probably not the tier for that. And then we have the long-term archiving storage class. This is a very interesting one. So yeah, like under this category, we have 3 storage classes. Again, we have the Glacier instant retrieval, the Glacier flexible retrieval, and the Glacier deep archive, right? So for these tiers, we tend to use them to store those code data, as I mentioned earlier. Like maybe it's an event from like 5 years ago in your time series database. So we still kind of want to keep that just in case, but we don't access it for a long time at all. That could be the case. That could be the case, right? So these tiers they tend to have like much lower storage costs, but when we need to access them, except for the instant retrieval tier, the flexible retrieval and the deep archives, we need to wait for a while. So once the data is written and we want to read it back, maybe it's even like written last second, and now we want to read it back. We cannot do that, and we need to restore the data first, and then we continue our reading from that. There are rumors saying that AWS may use long-term storage, super reliable tapes for Glacier deep archive. It's never confirmed. It's just a rumor, but I think it's a reasonable rumor or a reasonable guess as well, right? Because we need like the extremely low storage cost, and we can wait. We can wait for the tape to roll. And lastly, we have something called the S3 intelligent tiering, right? So it's something, maybe we don't know the pattern, the access pattern of our data, and we can rely on S3 to do the intelligent tiering in this case. So we're going to cover this particular tier later as well. It's a very interesting one. So yeah, as I always say, and I mentioned earlier, there are always trade-offs, right? So let's take a look at the storage cost first in this case, right? So for the standard S3, we tend to have roughly 2 cents per gig per month, right? And for on the other extreme, when we have the S3 Express 1 zone, which is the fastest one, right? So the storage cost is higher. It's roughly 5 times that at a dime per gigabyte per month. And then on the code data side of things, let's take the extreme example, the S3 Glacier Deep Archive. That's around what, 1/10 of a cent, right? So yeah, to recap, Express 1 zone is 5 times more expensive than the standard, and the standard is roughly 20 to 23 times more expensive than the Glacier Deep Archive. So that's for storage cost, but storage cost is only one side of things, right? On the flip side, let's take a deeper look into the pricing page of S3, right? So there are a few other pricing categories as well, right? For example, um, first of all, the archive storage classes, they normally have like a minimum storage duration requirements. So when you write something to S3 Glacier Deep Archive, even it exists for 1 second, you're gonna get charged for 180 days. So that's the minimum requirement. So you are not supposed to delete that immediately. So think twice, right, before you dump the data into this tier. And very similarly, they also have minimum storage size requirements. So if you write like very small files to S3 Glacier Deep Archive, yeah, they charge each of the object to up to a certain threshold, right? So if you write like a very tiny file, you still get charged for maybe 128 kilo. I'm not sure about the exact number, but that's the case. You get to charge to the minimum threshold in terms of storage size. So that's for storage, some additional storage. Now, let's say we want to access the data, right? So as I mentioned earlier, for deep archive, we cannot read the object directly. We need to retrieve or restore them first before we can issue the general get command, get object command, or get object API to S3. So they need to be restored first. So when we restore them, we get charged as well, right? So for S3 Glacier Deep Archive, we have two sub-tiers for data retrieval. One is called bulk, and the other is called normal or standard, right? So if we read like a bulk, we do like a bulk restore, that's how much we're gonna get charged. And if we do like a normal, it's also more expensive. And similarly, we get charged by how many requests we make to actually retrieve or restore the data as well. So yeah, we say we use the normal restore. That's a dime, 10 cents per 1,000 requests. And all this pricing, they don't apply to S3 standard, because for S3 standard, the data is always there instantly available. So we don't need to do the restore step first. So that's a difference for when we access data, in these tiers. Yeah, so that's one thing. And then Now we're able to read the data because they're restored, right? So for read and write, let's go with read first. So for read, after the data is restored in S3 Glacier Deep Archive, then the price is the same for the Deep Archive and for standard, right? So when we usually get objects, it's the same thing for both. But when we actually need to write to these two different storage classes, they're different as well, right? So the S3 Glacier Deep Archive, yeah, that is 10 times, right, more expensive than standard when we are writing objects to it. So to recap, there's always trade-offs, and for the deep archive, for the Glacier tier, we tend to have much cheaper storage, but we're not supposed to modify it a lot. So we write it once and we leave it there for a very long time, and we access the data very occasionally. That's the right usage pattern for this type of Glacier or archive tiers or storage classes. Otherwise, we need to rethink about it. It's probably not suitable for the archive tiers. Awesome. So now let's see what we can do to use JuiceFS to utilize this kind of storage classes, right? So in JuiceFS, so because JuiceFS is a software-defined storage solution, right? So we don't actually care, or how I put it, we cannot control what's the actual medium underneath the object storage they actually use to store the archive data. It could be tape, it could be other things. We don't have control. But what we do have control is the storage class API, right? So when we store an object in object store, we specify the storage tier in the header, in the request, so that we take the advantage of that, right? And before JuiceFS 1.4, we have something similar, but it requires you to specify the storage class when you mount the volume, the JuiceFS volume, right? So it's kind of like a feature we have before, but the granularity was not good enough, right? So you need to predetermine or decide that this entire file system, the mounting point is of a specific storage class. But now with JuiceFS 1.4, we have more flexible and dynamic configurations for this, and we push down the granularity to level 2 directories and files. So you have granular control of your directories and individual files where you want them to reside in the object store. All right, so let's see how we achieve this, right? So first off, the first step when you're using this feature, you need to do is configuring the tier mappings, right? Because JuiceFS supports plenty of object storage services, right? So each of them, they may call different storage classes differently. So we don't know, like, we don't want to manage all of them, right? So what we do is that we let you, the user, to specify a tier mapping to a specific storage class of the object store, right? So storage class is a concept of the object store, and tier is the concept on our side. And this way we give you like the most flexible way of configuring this, no matter what kind of object storage service you're using. And yeah, you can also just pick some of the storage classes that could be beneficial to you. So currently we have 0 as the default tier on the JuiceFS side, and tier 1 to 3, they are configurable, and you can map them to the underlying object storage we'll be using, like this. And these names, like standard IA, intelligent tiering, and Glacier IR, they are, you need to look for them in the object storage provider or the cloud provider's documentation. So for example, we're using S3 in this case, so these values has to be recognizable by S3, right? So in this case, we use tier 1 as the default, which is S3 standard, and 1 as the standard infrequent access, tier 2 as the intelligent tiering, and tier 3 as the Glacier instant retrieval in this case. So we configure the mapping first. Once we have the mapping, then we can start to set tiers for directories or files, right? So we don't specify the actual storage class name here anymore. We are using the tier ID or the tier number we configured in this step. And in here, we can set tiers for files or directories, right? So for example, the first command, we're just setting a tier for a single file. And in this case, we're setting the tier for a directory, but not recursive. So what this means is that anything that are existing in the directory, they will stay the same. But once we set the tier of a directory to maybe a different storage class, then all the new files, they will inherit the new tier, right? And we also have the -r option, which we just process recursively under this directory with all the subdirectories and files. Right? And then, this is like quite similar. We just set the tier back to the default, either to a file or to directory recursively. All right, so that's the basics. We will have like a demo after this very soon. And then there are some like slightly advanced topics that I want to cover just in case as well. Right? So the first one is called like rewriting objects after the mapping change. Right? So compared with the recursive command, we also have this -- force option. So this will force the storage tier under the directory recursively, and it will process all the objects underneath. So the difference between without using the force flag is that you can imagine that two scenarios I can think of. First, maybe you have concurrent client that's changing the configuration at the same time, right? And when you use the force, then this one is the one that wins, that will take whatever configuration written by this client, and then we start to process all the objects underneath. Another example could be you change the mapping from the tier ID to a different storage class, right? So from the metadata engine's perspective, the tier ID 2, it doesn't change. But now the tier ID 2 may be mapped to a different storage class on the object storage side of things, right? So when that's the case, we also want to use the force flag in order to reprocess all the objects. So yeah, that's something that is super powerful, but also when you do this, especially when you're changing something from like an accessible tier to an archive tier, because after you've done that, you won't be able to access the archive tier like instantly anymore, right? So still think twice. It's all DevOps jobs, and you need to be careful. Treat it as like a DBA command. Right? And then, yeah, this, as I mentioned earlier, for the archive tiers, we cannot access them directly, right? So what we can do is that we use the subcommand, the JuiceFS tier restore, and then we use the metadata engine URL, and then we specify a path to a directory or maybe to a file. In this case, it's a directory, and we use the -r to process the files recursively, so that we send a restore object request to all those objects underneath that archive tier. But even after that, we still need to wait. We cannot read the data immediately after restoration. So it's totally depending on the object store, how fast they can restore the archived objects, right? But one way you can track that is you can use the JuiceFS info command, and you choose a file, and yeah, you wait for the state to become ready, and then you will be able to read that file. And also, once the object is restored, it has like a default retention period in the accessible state as well, right? So by default, it's 3 days. I'm not sure, but I will double check. We can potentially expose that flag to our users as well, so that you can specify your expiration for restored data as well. Awesome. So that's yeah, that's the basics and the slightly advanced pieces that I've covered. Now let's see it in action. And let me switch back to my terminal over here. Awesome. So now I have like this machine, and let's double check. So I have a JuiceFS volume already mounted, right? So I'm using in this demo, I'm using SQLite as the metadata engine because I don't need other extra services, but it's the same idea for any other metadata engine as well, because when we set the tiers, we're actually configuring the metadata engine, right? So, and let's also double check that I don't have anything in the JuiceFS mounted drive. Cool. So that's the prerequisite. You have a JuiceFS volume created, and you have a mounting point for that. So now let's try to set the first step. We try to set the tier mappings from the JuiceFS tier to the object store storage classes, right? So let me just take my command here. So I want to, again, tier 0 is the default, and I want to set tier 1 as intelligent tiering. I've ran this before, so it says nothing has changed, but let me just rerun all of them so that you can see. Same thing for tier 2. My tier 2 is already standard IA. Now let's see tier 3. I'm setting it to Glacier instant retrieval, right? So you see that it is changed from deep archive to Glacier instant retrieval because previously I set it to deep archive. Okay, but this is what I need to demo later. So let me just switch it back, right? So now I'm setting tier 3 again to S3 Glacier deep archive. Cool, so that's successful again. All right, with all these things set, let's just verify again. So I'm using the JuiceFS tier list command, and I'm just specifying my metadata engine URL. So now we have 0 as the default tier. We have 1 as the intelligent tiering, 2 as the standard IA, and 3 as deep archive. Awesome. Cool. So now let's try to create some files, right? So now let me create a file directly under the JuiceFS, the mounted file, the mounted volumes root. So I'm calling it the root file, and it has this content. Okay. Now let's take a look what what information the root file has. Because we haven't specified anything for this file, so you should use the default tier, which is the standard tier, right? So as shown here, my root file under the JuiceFS root folder of JuiceFS, it is using the standard tier. Awesome. So now let me try to set it to a different tier for this single file, right? So I'm setting metadata URL tier 1, which is intelligent tiering of S3, and I'm specifying only this file in this case, right? Cool. So now it's set, right? And then we can, run the info command again. You can see that this file now belongs to the intelligent tiering tier. And because intelligent tiering, I have more to share for this particular storage class later, but intelligent tiering, as you can tell, like S3 is managing, it's determining the hot versus cold data, right? So in this case, it's still hot, so there's no problem for us to read back this root file in this case, even though the storage tier or the storage tier and the storage class, it has been changed from the default standard to intelligent tiering. Awesome. So I think that's good so far. That's for a single file. Next, we want to see the operation on directory. So now let me make a directory first in the mounted drive called myDLR, and then I'm going to create two files in that directory. Right. So let me run JuiceFS info and then do mydir file one, because this is under the directory. And also lastly, when we change the tier for the root file, we're only operating on that one file, right? So in this case, both file one and file two under mydir, they should have the standard tier as well, which is the default. Okay. Now let me change now let me just list the tiers we have again here. So 1, 2, 3, standard, intelligent, standard IA, and deep archive. Now I'm changing my storage tier for my dir directory under JuiceFS to tier 2, which is standard IA, right? But I'm not doing it recursively. Okay, so after I'm done that, let me create another file, the file 3. Now the file 3 is a new file that's going to be written to the mydir directory, and it should inherit the storage tier of the directory of the folder because we changed it, right? So let's see if that's the case. Cool. So now let's double check. So back to file 1, it's still standard because it's created before we changed the storage tier for the directory, right? Same thing for file 2. It was written before we changed the storage tier for the directory. Now for the file 3, it is standard IA because we wrote this file after the fact that we changed the storage tier for mydir. Awesome. So standard IA is also a tier that's still readable, so we shouldn't have any problem read this file back instantly. Cool. So we have the content here. All right. Lastly, let's try something a little bit dangerous. And this is something that you should keep in mind when you're doing this in production too, right? So let me put it up here. So what I'm doing right now is that I'm changing the storage tier for myDLR to tier 3, which is deep archive that we set previously. And we're using -r and -force in this case. So we're processing all the files and subdirectories under this folder, and we're also rewriting all the objects. But tier 3 is deep archive tier, which means that once we run this, we won't be able to read the file back instantly anymore. If we want, we need to restore and then read, right? So yeah, always think twice or 3 times or more when you run this kind of commands in production, because it could impact your application if you're not careful, right? But in this case, let me just try that. Awesome. So I have set the storage tier of mydir to tier 3, which is deep archive, right? So now let's try to see the file information again. File 1, deep archive, file 2, deep archive, and file 3, deep archive, right? So now all these commands are metadata only operations where we're not going to the object store, right? So we can still retrieve this kind of information from the metadata engine. Cool. So now let's try to read the file, right? So surprisingly or not, we can still read the file, right? That's because JuiceFS has multiple layers of caching. In this case, I have the local data cache. We also have the kernel cache. That is the reason why I'm still able to read the file. But if we clear the cache here, then we are solely relying on the object store to read the actual file blocks or file chunks, right? But in this case, the objects they're in deep archive, so we cannot read them back. Let's try that. So let's see, I have the config, and I just need to remove this cache folder. Yeah, also something to be careful when you run remove RF. Awesome. Then let's also uh, clear the kernel cache too. All right, so now no cache. When we need to read a file, we reach out to the object store, right? But now, as I mentioned, because all the objects, the blocks that's related to file one, they're in deep archive right now. So AWS wouldn't allow us to read it immediately. We need to restore it. And then from there, we can read again, right? So with that said, then you try to restore that too, right? So now I'm running JuiceFS tier restore and using my metadata URL. And then I want to restore this entire directory recursively. Okay, so now it's issued successfully. The command is sent to S3 as well. But as I mentioned, the restoration for deep archive, it typically takes hours, sometimes 12 hours, sometimes even more, depending on the data volume you're asking for, right? But so which means that we still cannot read the actual file. But if we run the info command, we can see that we have sent the restoration request to S3. And because it's deep archive, it will be like this for hours. And then after that, we'll be able to check to read the file back. Cool. So that's the demo for today. And if you go to the S3 or your object storage service page and you find the bucket and that particular, this particular chunk, you would see the same thing. You would see, which tier we're using for this chunk. Yeah, as listed here as well. Awesome. Back to that went well, to be honest. The demo guide is not always with me from time to time, but today I think we practiced, rehearsed it enough, and JuiceFS is robust as well. There's no surprise for today. Awesome. Some best practices that I want to share with you when you're using this feature, right? So let's see what we can do with this feature, right? So a few obvious examples in this case, maybe you have existing data, right? That you know that everything in this folder, we don't need to read them for a long while, but we still try to keep it. So when that's the case, you can use the set here -r--force command, and then you do a batch rewrites of all the things under a specific directory. And we're using the copy object API to achieve that. So we're using the copy object, but we're using the exact same path. So we're not creating a new like path within the object store and then delete the old one. We're reusing the same one, right? So that's something you should keep in mind too. And then for the new data, if you have like very clear rules or very clear logic in your application, you know that, oh, this is just something we can archive immediately, then maybe set up a folder just for that and using the archive tier or maybe slower tiers for that as well, right? So yeah, those are like the first things that I can think of when you're using this feature. Yeah, and then as I mentioned, you need to be careful about data restoration because depending on the storage classes, it will take time. So I'm still thinking of the tape rumor because yeah, I'm just thinking like when it's running, we're gradually retrieving the data, and it's super reliable, and it's super inexpensive, but it just needs time to restore. Right? And also careful about bucket versioning too, because as I said, when we are when you are changing the tier of a folder, we do a copy object rewrites of all of them, right? So the object stays the same, but the storage tier or the storage class is changed. In that case, if you have versioning on, then your previous version still stays in your maybe your standard tier, like your faster tiers, and it will cost you a little bit more until the version expires. So you should keep that in mind as well. Right? And if you're not sure, I'd say go with standard because that's what we use every day. And if I don't tell you the whole story today, you don't even realize sometimes, right? And also intelligent tiering is also another tier that's interesting. I'm about to share very shortly. And always refer to your documentation and the pricing pages of the object store service because that's where I personally found all this information, right? And about intelligent tiering, let me just share a little bit more information. So this is something that S3 offers. And under this tier or this storage class, it has very similar sub-tiers, right? Frequent access, infrequent access, archive instant access, archive access, deep archive access. These are all sub-tiers of the S3 intelligent tiering storage class. Right? So by default, only the first three, they are enabled. So your data stays in frequent access. If they're not accessed for 30 consecutive days, they get moved to infrequent access. And if they are not accessed in 90 consecutive days, they're moved to archive instant access. But all these three tiers, you can still access the data without restoration, which means that you may have higher latency when you're reading from these, but you don't need to do the restoration. And these three are the three ones that are enabled by default. But additionally, you can configure things like archive access or deep archive access. Right? For example, if you enable archive access and you use the default, then this one, the archive instant access tier is skipped because once it reaches the 90 days, you won't go here, you go down to the archive access, just as an example, right? So when that's the case, your data can potentially fall into these two tiers if they're enabled, where restoration is required, which means that in order to read, you need to restore first, and then you read. So you're, on one hand, leveraging all this intelligence, tiering feature of S3, but on the other hand, you have slightly less control of what you're doing because we don't count the days for every single file, right? So yeah, again, it's a very powerful, very interesting storage class, but use it with caution. Personally, I would suggest if you do use go with the default. So all the top three tiers, they're enabled. So you still have instant or near instant access to the data. And then you do the archive side of things yourself using the JuiceFS tiering, right? Because you have like less control in this case. And if your application just blindly try to read something, it could be in the archive tier and you get an error. And we've seen like good use cases like this. There's a blog post. If you search for dev DOSV SV, this article will come up. It will show you how the intelligent tiering storage class is helping them saving money just kind of automatically, right? So that's a very interesting. So I say combine this with JuiceFS tiering, then you can make it even better. Right? Yeah, this is the example I kind of showed you. I kind of explained earlier. It's from the storage class doc of S3. So if you do enable the archive tiers for intelligent tiering storage class, then you need to program your application so that they're aware that anything you read could potentially be, could potentially need restoration, right? It might be similar for JuiceFS tiering, but you have more control. You know that, oh, this folder is not supposed to be read for the live application. So you have more control and more confidence. So always about trade-offs like that. Cool. So yeah, that concludes it, and that's all I have for you to share today. And thank you so much for listening. And let's see if we have questions from the community. Thank you so much. So the question from Randy is, can JuiceFS match JuiceFS with speed for petabyte scale custom video files on a local Kubernetes cluster? Which cache, read ahead, block size, metadata, object storage settings provide the performance? Cool. So yeah, that's a good question. My take on this is that yes, definitely we can. Um, like I don't know like the exact metrics for the GSFS read speed, to be honest, but we do have uh, like a case study blog post explaining. Um, well, it might be different. It was for video rendering, but it requires high-speed reads and writes too, right? So my take on this is definitely doable, but in terms of the actual tuning or the configurations, we need to see your environment, or we can help with your environment and learn more about your workloads. So it's always not easy compared with, for example, for in a database, I need to query on this field. I can create an index maybe concurrently. For a file system, there are many ways of using that. So yeah, we cannot know like all the possibilities of the commands, the POSIX APIs that the application or the workloads actually issued. But yeah, we do have similar use cases before. So yeah, if you have time, yeah, please reach out to us. We can set up something and learn more about the particular use case you have. Yeah, and maybe King has something to add if you do, because King is very experienced with like solving difficult problems with our customers too.
Well, for this one, frankly, I'm not very familiar with this GFS. But like Joe say, we actually have a dedicated chapter in our documents website to how to evaluate the performance using the open source performance testing tool FIO. So if like you're gonna trying to evaluate the performance, I encourage you to go through the document page and matching your application payload. And you mentioned about Kubernetes. Yes, we have a CSI driver which allow you to use into JuiceFS in Kubernetes. Um, uh, yeah, I think for the compatibility standpoint, you can also see that we support a lot more object storage. But just a quick look of the JuiceFS. But again, I'm not very familiar with that. So I think for performance, it's actually you have to do by yourself if you want to compare this uh, uh, to implementation of high performance file system. Yes.
Yeah. Also, I think caching plays a very very important role in this case as well. So um, you know forget everything we talk about today because it's about tiering on the object store side, right? Just using the standard tier and using JuiceFS normally in this, enclosed environment, there's still hot data and cold data, right? Whereas the cold data is the one that's in the object store, and the hot ones are the recent reads, for example, and they could be in your local cache, they could be in the kernel cache. If you're using JuiceFS Enterprise, it could be in the distributed cache group as well. So yeah, that obviously plays a very important role because we don't want to go to the object store every time. So yeah, then today we added the tiering on the object store side as well. So I think it's very interesting if you think it that way. It's always tiering, like the pyramid of the CPU registers, so 1, 2, 3 caches, memory, disks, and everything. Yeah, all the problems can potentially be solved by adding another layer of caching, but you need to invalidate it. Awesome. Let's see if there are other questions. If not, that's cool too. Please reach out to us um, using our Discord server or uh, you know the GitHub discussions. I forgot to. I'm just trying to find that slide. To be honest, but yeah, you know where to find us. If you're shy today, don't worry. But yeah, you can always reach out to us like so. Yeah, cool. All right. I think we can conclude. What do you say, King? We're good today?
Sounds good.
Sounds good. Awesome. Thank you for hosting, King, and thank you everybody for joining. Yeah, again, if you have additional questions, please reach out. Using the following ways on screen, and we'll always be there for you. Any questions, JuiceFS, any questions, storage, maybe any questions AI related to, we'll try our best. Thank you.
Thank you. See you guys
All
next
right.
time.
See you next
Bye.
time.